Concepts of Kubernetes networking. And towards the end, I will go over some of the different network plugins that you would hear when you are trying to bring up a Kubernetes cluster. So we have like Flannel, Calico, and Canal. These are the some of the popular CNI plugins. So we'll go over this. So here in this picture, on the left-hand side, I have, let's say, two nodes. These are like two virtual machines. They could be like two bare metal servers. And here you can see, on the left-hand side, the node one has a network adapter, which is Ethernet 0. And it has its own IP address, 10.129.1.101. And the node 2 has 102. So when you install Docker and when you run a container, what happens is that Docker creates this container and it connects this container to the Docker 0 bridge using a VETH pair. And this container can then reach out to the internet or to other nodes. But to expose any of the services which are running inside this container, you have to ask Docker to expose or publish this port. So for example, here, we are publishing this web application on port 80. So then what happens is, Docker configures a bunch of IP table rules, which will enable the outside traffic uh, when it is landing on port 80 to be directed towards this container, which is a web application. So that's a high level overview of how Docker networking works on a single node. Now, let's say if you have another node where you have a database container, and if you are publishing like the database port, which is 3000 on the node as a port 9000. So if the web application has to communicate with this database, it has to use this publish port unless you have some kind of overlay network which is running on this particular cluster. So the basic Docker networking does not provide any kind of cross node connectivity. So that is the reason you need some kind of a overlay network or some other network plugin which will enable communication between containers running on different nodes. Now on the right hand side, what happens is, it's a similar setup. You have a bridge. In Kubernetes, it's not Docker 0. There's a typo here. It could be like a flannel bridge, or it could be a CBR 0 bridge, depending on how you install your Kubernetes cluster. The main difference here is each node gets its own subnet. So on the left-hand side, you can see the Docker bridge on both the nodes have the same IP address configured, 172.17 subnet. Whereas on the right-hand side, the two nodes have two different unique subnets, and which are also configurable in Kubernetes. Because these these bridges have unique IP addresses, the containers also get unique IP addresses in a cluster. Whereas in Docker networking, you can see on the left-hand side, both the web application and the database containers, they get the same IP address. So it's very difficult, or it's nearly impossible to identify these containers uniquely, and they cannot communicate with each other using the container IP address. But whereas in Kubernetes, each container gets its own IP address. And the rest of the things are very similar to how Docker works. You have a bunch of IP table rules which do a lot of packet mangling, and things are routed either outside or inside, and they make their way into the container. So that's a high level overview of how networking works is in Docker and versus Kubernetes. So summary is like in Docker, the basic Docker doesn't enable cross node connectivity. You need an extra plugin. Whereas in Kubernetes, using a CNI plugin, the cross host connectivity is taken care of. In terms of networking, we need to understand few terminologies of Kubernetes. So the most important one is a pod. So pod is nothing but two or more containers running together. At the very least, you need two containers. So the reason for that is because there is a container which is called the pause container, which provides the networking stack to the application container or the actual container, and the other application containers share this network stack from this POS container. And here at the bottom half of the screen, you can see if you want to simulate a pod, what happens is you would create a POS container, or the first line, you're doing a Docker run dash dash name pause, and that's providing the network namespace. And then second line, you can see you are running docker run dash dash name, the actual application, and you are specifying that, hey, don't create your own networking stack, but instead use the networking stack or networking space of the POS container. So that's the high level overview of a pod. So to summarize, it's two or more pods. The primary pod being the POS container, which provides the network namespace, and the application pods run on top of it. And like I mentioned earlier, depending on how many nodes you have in a cluster, each node needs a unique subnet. So in Kubernetes, what happens is, you specify a bigger subnet for the entire cluster, and you specify how you want to chop it up into smaller subnets that can be allocated to each node in the cluster. So for example, on the left-hand side, you can see, for strategy one, where you can specify 256 nodes for each, 256 IP addresses for each node. And on the right-hand side, you can specify 128 nodes 128 IP addresses for each node. So depending on how you chop it up, you can adjust the number of IP addresses that you have for your pods on a particular node versus the number of nodes that you can have in a cluster. If you are using strategy 2, you can run more nodes in the cluster. Whereas if you are running strategy 1, you can run more pods on every node. So which strategy to use, it really depends on your actual business use case. The main thing to remember here is, this pod network seeder, it should not overlap with any of the IP address ranges used in either the host or outside of the host. So we have to make sure this is like a unique subnet. And then on top of this, there is one more concept called cluster IP. So a cluster, so if you remember, on the right-hand side, you have these pods running on node 1 and node 2. Now, if a pod container A wants to talk to container B, you could directly use these IP addresses. But generally, what happens is, if you don't use the IP addresses directly, but rather you create something called as a service, which is an indirection to reach the actual containers. So the reason for that is because, let's say you have uh, three containers which are running for your database. Now, if your application is trying to connect to those three IP addresses, how do you load balance? It becomes cumbersome. But if you expose the database using a service IP or a cluster IP, what happens is you just get one unique one IP address that your app has to communicate with. And if you are scaling up or scaling down, if any of the pods move from one node to another node, or if there is a failure, all of these things are abstracted behind the service IP. Your application doesn't have to worry about, hey, one of the containers is missing, so I need to remove it from the database. It's all taken care by Kubernetes. So a cluster IP or a service IP is an abstraction or an indirection to reach the actual containers backing that particular service. And this is totally virtual. There are no network interfaces created or associated with a cluster IP. It's totally virtual, and it's implemented using IP tables on the host. Now for this cluster IP addresses, you need to specify a certain IP address range. So you have to make sure you can select whatever subnet you want, but make sure it's unique to your cluster, and also it doesn't overlap with any of your other services running outside of your cluster. It can be like a /16 or /17 or /24. It depends on how many services you are planning to use in the Kubernetes cluster. And um, uh, instead of trying to use the cluster IP address directly, you're trying to access your application, you could use logical names. So what you can do is you can use the service name dot the namespace when you want to access your uh, application that is running in the cluster. Now, for example, let's say you have two namespaces. Let's call them NS1, and the other one is NS2. And in namespace one, you have a web application, and in namespace two, you have a database. Now, if your web app has to talk to the database, instead of using the IP addresses, like for example, if you are trying to access a website, you don't go and type the IP address, right? You type in the FQDN, like yahoo.com or google.com. In the same way, it's easy to work with these names rather than with IP address. So here, if you want to access the database, what you can do is you can say database.ns2 instead of specifying whatever is the 10 dot some service IP that's allocated for the database service. So it's a friendly feature. It helps with the use of these names for accessing your services. The component that is responsible for providing this service discovery functionality in a Kubernetes cluster is a CubeDNS. And these are like a bunch of pods which are running in the Kubernetes cluster, and it gets its own service IP. And when a pod is created, in the resolve.conf of the pod, the service IP of this CubeDNS is mentioned. So that way, whenever you want to resolve the DNS, the DNS queries are sent to the CubeDNS, and if CubeDNS is able to figure out that it is an internal FQDN, it'll resolve. If it is not, it'll forward it to the upstream DNS servers. Now, if you have services, like for example, database running in your Kubernetes cluster, or if your web application is running in your Kubernetes cluster, it is contained to run within your Kubernetes cluster. How does it, how do you expose it to the outside world? In the Docker world, you would just use -p and then specify what port you want to use from the node, and you would expose it. So the host port in Kubernetes is the equivalent of this expose port in Docker world. So this is one way of exposing your applications outside of the cluster, but this is not a recommended approach, because what happens if the node dies where your pod is running, and there are no nodes available with the desired port, right? So it's just not, then the pod is not going to run because there is no port available to bind to. So instead of using host port, you could use a concept called node port, which is very similar to the host port / the publish port. The thing is, instead of when you say host port, the port is reserved on just one node of the cluster. Rather, if you specify node port, the same port number is reserved on all the nodes of the cluster. With this, what happens is, let's say if one of your nodes go down, then the pod which is running on that node can move to the other node without having any kind of a port conflict. It can just move to a different node and start running. So this is the recommended way of exposing your services outside of a cluster. And there is an even better way of running exposing services outside of your cluster, which is called ingress. So ingress is specially designed to expose web applications either via HTTP or HTTPS. So node port is useful if you are trying to expose any TCP services. Like for example, if you are running a chat application, it's not a web application, right? So you want to expose it to outside world. So you would use a node port. Any questions so far?
Yeah, there is one question.
Okay.
So it's related to IP addresses, I think. So it's asking, what if the pod IP or cluster IPs are exhausted? Can we add additional blocks without impacting existing workloads?
So unfortunately, it's not so easy to add like the, the pod seeder IP addresses to a running cluster. So this is generally something that you would plan for when you are creating a Kubernetes cluster. Like you need to make sure that you do capacity planning before you start running your Kubernetes cluster. Otherwise, you will have a lot of issues. So probably if you are thinking on like exhaustion, then you have to ask yourself like, hey, how many nodes, how many applications, how many pods, why am I running it at such a scale, and things like that. So yeah, you shouldn't reach the exhaustion state. Ideally, you should plan for it so that you have enough IP addresses left.
All right, I think, yeah. Let's continue with, yeah. All right.
Okay, cool. So the next major topic is network plugins. So in Kubernetes, when initially it started, the Kubernetes had a certain way of um, setting up networking, and to make sure like the networking is not dedicated to a particular vendor or a particular provider. The folks, what they did is they came up with this interface, or an API interface, which is for specifically for networking, and it is called container networking interface. So in this, like as part of this API, it lists down like, hey, you have to implement these functions or these functionalities so that Kubernetes can call or invoke your CNI network plugin and take care of networking for you. Because of this API or the CNI interface, there are so many options available for use when you are trying to create a Kubernetes cluster. The default is Flannel, which we will cover in detail a little later. And there's a popular project called Calico, which provides, which is popular for its layer 3 functionality. And there are like a lot of other plugins. And if you look at the current ecosystem, like for example, if you are looking at AKS, which is the managed Kubernetes service, they have their own way of doing networking. In the same way, Azure Cloud has their own CNI plugin. So all this is possible because you have something called as CNI. So with CNI, the main difference between Docker network versus CNI network is, when a pod starts, Kubernetes starts it with network equal to none, so that the Docker functionality of creating a V and binding it to the Docker bridge, it doesn't kick in. So basically, Kubernetes is bypassing the Docker way of setting up networking, and it does set up the network outside of Docker's visibility. And that's why, when you do a Docker inspect of any of the Kubernetes containers, you will see that the networking is set up as none. It might be a little confusing, like, hey, I have networking, all the things are working, but how come the Docker inspect doesn't show the networking information? That the reason is because Docker and Kubernetes, they did not get along well in the initial days, and then Kubernetes just decided, hey, I don't want to fight with you, Docker. I'll just ignore or set up network equal to none, and then I'll take care of networking using CNI. So that's the reason you would find the networking section in the Docker inspect to be none. And these CNI plugins are of like various types. Some of them provide overlay network. So when I say overlay network, what it means is the networking between containers is set up on top of the existing network topology. So this is very favorable for running containers in the cloud, because in the cloud you don't have any control over the infrastructure, and you can't just ask, hey, give me this subnet from the underlying network infrastructure and then I want to use it for containers. That's not possible in the cloud. But if you own the underlying infrastructure, like for example in a data center, then yes, then you can go and use non-overlay options. So in the so in overlay, the most popular one is VXLAN. The main reason being the overhead of using VXLAN is very less. So that's why it's very popular. But the downside of that is, all the encapsulated traffic between the nodes is unencrypted. So you can pretty much see things in clear if you do a packet capture. And in the non-overlay option, like, you have something called as a host gateway plugin and things like that. So there, you would directly connect the containers to the underlying network infrastructure. And Flannel provides various backends. The most popular one is VXLAN. Calico provides a VXLAN backend as well as a layer 3 backend. And Canal is nothing but Flannel plus the network policy controller of Calico. So with Flannel, you cannot configure network policies. You can configure network policies, but there is no controller to take action on. But if you install Canal network plugin, you can get network policy support. It's basically nothing but Flannel plus Calico. So like I mentioned, like, Flannel supports multiple backends, VXLAN, IPsec. That's the overlay backends. And in the non-overlay, you have something called as host gateway. The reason why somebody would want to use host gateway is for better performance. Like, 5 to 10% is the overhead when you use VXLAN. You don't want to do that. Incur that extra cost. Then you can use this host gateway. And for example, if you look at AWS VPC, they have their own way of doing overlay. They have their own CNI, just like Azure. So you can use those non-overlay options for Flannel. And then, like I mentioned, there is no out-of-the-box network policy support for Flannel. Here is a high-level picture of how Flannel looks like. So we have a similar picture that we saw earlier in the presentation. So you have 3 nodes which are part of a Kubernetes cluster. Now, the main difference is you have this CBR bridge, which is the bridge created by Kubernetes, and all the pods connect to this bridge, not to the Docker Zero bridge. And you can see here the IP address configured, or the IP address range configured for this bridge is unique on all the nodes of the cluster. And on top of it, you would see a flannel.1 interface created on all the nodes of the cluster. And again, it also has its own unique IP address. Now, this flannel interface is responsible for sending cross-host traffic. Like, for example, from, like, you have a pod running on node 1, it wants to talk to pod running on node 2. The traffic gets encapsulated if it is an overlay backend by Flannel interface. For example, if it is VXLAN, Flannel.1 is responsible for actually encapsulating the traffic and sending across to the other node. And on the other node, the Flannel decapsulates the packet and sends it to the right pod in the node. So this is the high level architecture of a Flannel with the VXLAN backend. Now, if you look at the host gateway backend, the difference is, there is no Flannel interface, and the IP address range which is allocated to the pods, it is recognizable, or it's understood by the underlying network infrastructure. So that means the packet from the pod running on node 1 goes unencapsulated out of this network interface of node 1, which is ETH0, and then the underlying network knows how to route the traffic to node 2, and then it reaches the pod running on that particular node. So this is the high level architecture of host gateway backend for Flannel. And the other CNI plugin is Calico. So in Calico, in the non-overlay mode, it uses something called as layer 3. So in layer 3, they use a BGP protocol, routing protocol, to send traffic from one node to the other node. And the reason why somebody would want to use Calico is because you get much better performance, and you can do like route aggregation and direct routing to the container workloads on your running on your Kubernetes cluster. And of course, it does support overlay backend as well. For example, you can use IP in IP encapsulation. I think it does support VXLAN encapsulation also. And this is, like I mentioned, like the overlay is not encrypted, so it's all in clear network. And Calico supports network policy. So there are two components here. One is the CNI network plugin, and then there is a network policy controller. The network policy controller is responsible for setting up the necessary things on the node to make sure the policies are enforced when the communication is happening between various pods in the cluster. And here is like a picture of high level architecture picture of things when you are running Calico. Now here you can see the difference between Calico and Flannel is there is no bridge here, and then there is no Flannel interface created. Now rather the pods are connected to the node directly using a VETH pair. So if you do IP address command, if you run IP address command on the node, you can see the one end of the VETH interfaces for all the containers running in your cluster, or on your node. And there are like bunch of IP table rules, routes, and other things set up on the node to ensure this cross host connectivity when depending on the backend. If it is an IP in IP, there are certain set of rules that are configured. If it is VXLAN, there are different kind of rules that are configured and things like that. So this is a high level overview of Calico's architecture. And Canal is a network plugin which is like a combination of Flannel and just the network policy component of Calico. And if you install a Rancher, that's the default option that you get. And of course, you can install other CNI plugins as well if you would like. So that's like the content that I had today. I did not pack in a lot of content because the main reason is I wanted to have enough time for Q&A and kind of have an interaction with whoever is attending this presentation.
Thank you, Murali. So we have some questions. So one is from performance sorry, from a performance perspective,
Yeah, I can
which
see it.
CNI
Which
is better?
CNI is
Yeah,
better? Yeah.
yeah,
So
yeah.
generally, like I mentioned, like overlay uh, backends of any CNI plugin will have less performance when compared to non-overlay options. So because if you take IP, like for example, if you take VXLAN, it just has like 50 byte overhead. So and also to encapsulate, there are some CPU cycles that are needed. So you get certain performance depending on how many cores you have, what kind of network interface you have, and things like that. You get a certain number. Now, if you look at IPsec backend, you need to have encryption. Now, if you have encryption, it's very CPU intensive. So you get like pretty bad hit in terms of performance, but sometimes it is needed. So, from performance perspective, any of the non-overlay options are good, and Flannel and Calico, they do support non-overlay option. Which one? It depends again on the actual business use case. That's my answer for
Right.
that question. And I can
Yes.
see the next question.
Yeah.
Uh, Azure AKS now supports Calico for network policy. Any advantage of using it compared to Azure network policy? I mean, I personally haven't played with Azure network policy. So I do not know, like, what the advantages might be. But my understanding, based, if I have to take a guess, this is just a guess, if you're running Calico, then you would probably use Calico's network policy controller. If you are using AKS underlying CNI plugin, you would probably use their network policy controller, and they might work similarly. And but I don't know what kind of performance differences are there unless you actually run some workloads, do some benchmarking. It's very hard to tell, like, which is better or why one would use that. Yeah, and maybe if you are using Azure Network CNI plugin, maybe they have better performance because they own the underlying network infrastructure. And if you have to use Calico, then you have to run maybe overlay, and you might get lower performance. So this it's a guess, because I haven't used it myself. And the next question is, what
Right.
should we consider most when selecting a CNI? It's an interesting question. I mean, based on my experience working with like so many customers of Rancher, um, these days the networking has become like a commodity, and most of the customers that I've worked with, most of the users that I've worked with, they just run everything like in a private VPC. If they're running in a in a cloud or in their own private data center, they just want some connectivity between their containers. And either overlay or non-overlay, it depends again on the business use case. If you're running in the cloud, you would want probably like an overlay option. And uh, um, and there are like few customers who are like really sensitive to latency. So and also some customers, they have like a specific need for special routing. And in those cases, like, they find Flannel doesn't have those capabilities. And the obvious option is like either use Calico or Weave. Weave is another CNI plugin that you could use. So either Calico or Weave, you can use that. So there are multiple things that you have to consider when you are selecting the CNI plugin. So like I mentioned, where your cluster is running, do you own the underlying networking infrastructure or not? Are you okay running non-overlay? If not, you want to use overlay network. And in overlay, which protocol do you want to use? Do you want to use VXLAN, or do you want to use some encryption enabled like IPsec? And on top of it, do you want to have network policy support or not? If you need network policy support, then Flannel is not a go. You need to use Canal or Calico. So like this, there are like a bunch of questions that you have to ask, and they you might have to answer them based on your business needs. So there's no one hard and fast answer to that. And then the one more question that I see is there any use of NAT in Kubernetes networking? Yes, there's a lot of use of NAT in Kubernetes networking. For example, if you are using Flannel, right? Now your pod is running on an overlay network. When it has to exit, when it has to reach to the internet or some other nodes, it cannot use its own IP address because the underlying infrastructure doesn't understand it. So then the container has to use the node IP address and exit the node to reach to the outside world. So this translation is set up automatically by Docker or Kubernetes. So that's a source NAT. In the same way, when you publish a port, a node port, or let's say you have a service, you have outside traffic entering the cluster or the node. Now, when you are getting that, the destination IP is the node IP address. Now that has to be translated in to the container IP address. So for that, you have destination NAT rules. So a lot of NAT rules are involved when you're running Kubernetes network plugins. So yeah, both source NAT, destination NATing functionality from the Linux kernel is used, and IP tables is what is used to program these rules.
Does anybody else have any questions? There is one from Robin. We will
Yeah.
ask.
Hi, Murali.
Hey, Robin.
I have a question. So let's say if we are exposing a service as of type load balance on cloud,
Mm-hmm.
so how does actually the load balancer talks with the application? Is it through the node port? So the load balance actually talks to the node port.
So I work with this type load balancer in AWS. So in
Hmm.
AWS, what happens is they create a service with node port, and they expose the service on some node ports of the nodes, and then there is a load balancer in front of it, which is probably like an NLB or an ELB, and that points to the node ports of the nodes of the cluster where your pod is running. That's how I have seen things set up. And this again can be dependent on how the cloud provider is implementing the type the service type load balancer. If you go to AKS Azure, right? It could be implemented in a totally different way. So it really depends on the cloud provider. And to be honest, like it should be like a black box for you shouldn't really have to worry about like how it
Yeah,
is set
yeah.
up.
All right, all right. Thanks, Murali.
Sure.
Um, yeah. Does anybody else have any questions? I can either unmute and ask or type on the chat. Not, I think we can wrap it up.
Okay, so I just wanted to ask, like, how are you guys working with Kubernetes? How many of you are actually using it in production, and what are your some of your use cases? If you can share, that would be like really helpful. I'm curious to see, like, how Kubernetes is adopted uh, in Sri Lanka.
Yeah. We are using actually for a customer CubeADM. We
I
have
see.
one of the clusters using CubeADM.
Mm-hmm.
And from what I know, some of our companies are using Rancher too.
I see.
Yeah, yeah.
I
And
see.
yeah, from the cloud, I guess AKs and GK are the ones we are using.
I see. Got it.
Yeah,
Got it. What company do you work for, Robin?
I'm a platform guy.
Oh,
I'm
same
from platform.
platformer. Oh, I
Yeah,
see.
yeah.
I see. Nice, nice.
Yeah, I'm Kasun. I'm from
Thank you, son.
yeah. So we are using a case for our application hosting. Actually, we are moving our current application to the Kubernetes these days. So we are doing our testing and development based on
I
that
see.
one.
I
Yeah,
see.
yeah. So actually, I think we contact Rancho also regarding this one because initially our application is running on the .NET. So
Hmm.
uh, but Windows node are not supported very well, and we face some difficulties. So we moved to the Linux nodes on the case, right? So
I see. I see.
yeah, so
Got it. Yeah.
now we are migrating our current application, and we are going to go live on the next month
I see.
and October. So I'm working
Nice.
with them in a very closely. So because I myself and my team is configuring the monitoring and security part of the cluster.
I see.
So,
Nice. Nice. Nice to see that. You're already running things in production. That's pretty impressive. Yeah, like you said, initially, like there was not good Windows support in Kubernetes itself, and I
yeah,
think maybe 116 or 117 is when uh,
114, I
yeah,
think.
114. Yeah,
Yeah.
114 is when they added the Windows support, and then there were like bunch of bugs that needed to be fixed in later releases. Now we support Windows networking, Windows Kubernetes clusters in Rancher.
And one question more
Yeah.
is, so yeah,
Mhm.
so in Rancher, there's a tool that we can use for the management, right? For the
Mhm.
cluster management through the
Correct.
multiple clusters, right?
Hmm.
So because in our environment we are trying to we have, I think we are coming about 9 clusters in the
I see.
different regions, right?
Got it.
So in that case, I'm wondering that as I'm responsible for a platform team, so that
Hmm.
we need to do monitoring and the cluster maintenance, those things kind of thing, right? So
Yes.
I'm wondering that we can how the rancher can be used for that one, because I tried there's a tool for importing already existing clusters to the rancher and do some,
Correct.
yeah,
Correct.
monitoring and management.
Correct.
Yeah,
Correct. So this is my install of Rancher, and here if you see, these are the different cluster types that we support. So you can use this option like EC2 Azure directly. So with this, what happens is we spin up the cluster and we run and manage the control nodes also when we create the Kubernetes cluster.
yeah,
Whereas if you use EKS or GKE, then the control plane is owned by the cloud provider. Only
yeah,
the worker nodes are managed by Rancher. And
yeah.
obviously, if you have your custom infrastructure and you want to use that, you have this option called custom, and you can use import an existing cluster if you already have like a kubeadm cluster that you want to manage in Rancher. And once you have, like, here you can see like I have two clusters, and in
Actually,
like for example,
actually, you have to switch the screen, I think.
oh, you can't
It's,
see the screen.
no, we can see the presentation.
Oh, I see. Oops. Thank you. Thanks for, let me share the entire screen. Okay. Can you see my screen now?
Yeah, yeah. Now you can see.
Okay, cool. So I was referring to this page when
Ah,
when you are in. So this is my install of Rancher, and
okay.
here if you click on Add Cluster, you can see the different options. So I was talking about like this row where the control plane is managed by Rancher,
Yeah,
and in the bottom row these are like the hosted Kubernetes or the managed Kubernetes services. And here you don't get an option to manage the control plane nodes,
yeah.
and you have custom and import option. And once a cluster is created, we have an option to enable, like if you see monitoring, we have an
Mm.
option to enable monitoring. And once you enable that, you can see, like you can get like a lot of um, metrics collected
Mhm.
from the nodes, and they are shown here. And you can see we have a very good integration with Grafana.
Okay.
And you can like use the dashboards that are provided by default for you, or you can create your own custom dashboards also. So this is
Okay.
like cluster level monitoring, and then you can configure project level monitoring, app level monitoring, and things like that. And to top it off, we have like these alerts.
Mhm.
So you can configure like, hey, if a certain metric goes above or goes below a certain threshold, create an alert. And then you
Mhm.
can see like, these are the different alerts that you can configure. These are the default ones. You can add your own custom ones,
Mhm.
and you can configure various notifiers. Like,
Okay.
you can configure Slack, email, PagerDuty, or whatever you prefer.
Okay. So in our environment, we configure Prometheus plus Grafana for monitoring
Yeah,
part.
same thing. Yeah, same thing. That's inbuilt into Rancher. So all you have to do is like go to this, install the cluster, go to monitoring, and click
Mhm.
enable. That's pretty much it. Everything else is taken care by us.
Okay. So if we are adding any custom dashboard for your Prometheus, it can be done, right?
Yeah, yeah. So basically, what you do is you can enable this persistent storage.
Uh-huh.
So that way, when you create your custom dashboards, the data is persisted, and you don't lose it. Let's say, for example, you disable or enable your monitoring on Rancher cluster,
Okay.
basically. But yeah,
Okay.
it's possible to create custom dashboards.
Okay. Okay. Thank you.
Cool. And then, like for example, if you are creating a cluster, let me show you how the CNI network plugins look like, right? So you create a cluster. This is a custom cluster. Here you can see, you can select the different CNI plugins, which we talked about, like Flannel, Calico, Canal, and Weave is not something that I covered, but this is also another popular plugin. And you can enable project network isolation and things like that. And if you are running on Amazon and you want to enable cloud provider, you can enable that, and you can select which version of Kubernetes you want to run, and you can click create cluster, and obviously you can configure like advanced options. Um, what you want to do, whether you want to run Nginx or whether you want to enable port security policy or not, what whether you want to take snapshots of your etcd. A lot of value added features are present in Rancher, which make the life of operator or the cluster admin very easy.
Yeah.
So basically, Murali, you can spin up a GKU AKS cluster through Rancher also. So
Yeah,
that's
yeah,
how.
you can. Yeah, correct. You can
Okay.
create from here. If you already have one, you can import it. If you are
Hmm.
starting of new, you can create from here.
All right. So basically, you provide the underlying cloud account
No, no,
management.
no. You provide your cloud credentials. Like for example, if
Ah,
you look at sorry, if I look at Azure, right? So here it'll ask for your subscription ID,
all right.
tenant ID, and things like that. So you have to bring in your
Mhm.
cloud, and
Okay.
we will create instances on your behalf, and we manage them.
And manage it. Okay. Okay.
Right. So the resource groups and everything are like predefined, like by Rancher, and it has its own name based on the
Uh,
cluster name.
yeah, yeah. I mean, they're all based on cluster name, correct?
Yeah. All right.
Yep.
Okay. I think.
And one
Yeah.
more
Sorry.
question.
Go ahead.
And RBAC
Sure.
can other stuff also managed by this control plane, right? So
Yeah,
let's
yeah,
say, yeah.
yeah. Security, like here you can see by default we have a bunch of
Yeah.
rules. Like hey, create clusters is a certain rule, and
Mm-hmm.
these are like the global rules. And within a cluster, what
Cluster
roles you
roles.
can have. Yeah.
Yeah. Yeah.
And
Okay.
when you are adding users, you can configure them like whether they are a user or an admin, or you can pick mix and match a certain set of roles that you want, or you can create custom roles and things like that. Yeah, we have very good RBAC integration as well.
Cool. Cool. Yeah. Thanks, Manoj. Yeah.
Sure. Any other questions or use
Yeah.
cases that you
Any
can
other
share
questions?
with?
Yeah, hi Murali, this is Upul.
Hi,
So
hi.
I want to ensure something. So that's why it is, we can use the planner, Calico, whatever the network plugins for use cases. Think about if we are using planner at the first time, so we can't enable to the network policies. I mean that security
Correct,
policies that is not
correct,
working, and we
correct.
can move the Calico if it is working. But I want to know it is easily switched to the those kind of networks, and we can use multiple networks with the multiple ports with
So
namespace wise
yeah,
or whatever. Yeah.
sure. So generally, we recommend not to not switch network plugin on the fly, because you need to restart a bunch of containers. You need to restart the node to make sure there are no leftovers from the previous network plugin and stuff like that. So you can't just switch over the network plugin type. And uh, so that was your first question. I missed your second part. Could you repeat the second question?
Yeah, the second part means namespace wise. So I mean separate the network plugins. So planners can use these kind of bunch of ports. So the Calico can use these kind of ports likewise. Can be
I mean,
separated.
yeah, I mean, there is
There
no
is no
like
need.
limitation. Yeah, there's no limitations from Flannel or Calico. They're like very similar. The only thing is you get the network policy support when you're using Calico or Canal. And is that what you're asking? I still am not clear what you are looking for.
No, actually, I mean if you are doing a port, that means if you are spin up the ports, there is no any option to the define the CNI. That means that spot can use this network if we are not any things to define it. No, I mean we can define it. That spot
Oh,
can use point planner, other one
oh,
use Calico.
got
Likewise,
it.
yeah.
So what you're asking for is probably like, for example, here in these drop down, you can just configure like this one, right? So what you're asking is like more additional options. So we have something called as edit as YAML. Under this, you can configure like a lot of the plugin related, what do you call, configurations. Is this what you're asking about?
Ah, yeah, yeah,
Yeah.
definitely.
Yeah. This is the edit as YAML.
All right. All right. Okay. Thank you. Yeah.
Yeah, sure.
Um, Anybody else have any questions? So are we good to? That's about it, right? Um, so yeah, uh, I think we have uh, near the end of the webinar session today, and this has been very informative, and I'm sure everyone was able to learn something that will help them at some point. I know I did, and so on behalf of the Kubernetes Sri Lanka community, I'd like to thank you, Murali, for sharing your
Sure, my
knowledge with
pleasure.
us. Yeah, and we really appreciate it. And
Sure.
also, for the rest of you, the next webinar, Camilla has already shared the link. So anybody who's interested, you can join it now, and we also post it on social media. I think yeah, that's about it. Thank you, Murali. Thanks a lot.
Thank you.
Yeah.
Thanks for this opportunity. It was nice meeting you all. I wish we could have met in person last year
Yeah.
before the whole COVID
Mm,
situation. I did get a chance to visit Colombo for a day
right.
and not a lot of time.
Mm,
Maybe once things settle down, and then we can probably
yeah, at
plan
some
to
point,
meet at some better event, bigger event. Yep.
definitely.
Cool.
Yeah.
Nice meeting you all. Have a nice one. Please feel free to reach out if you need any help.